Bum 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 bum. Gassed. I gassed every one of them. Hey guys, welcome back. This was a 12 volt 30 amp hour lithium ion battery, and it was made up of 3.2 volt 10 amp hour lithium ion cells, and at the top you'll see a load of wiring, and basically the Chinese engineer in China compared to the Chinese engineer in England wired these batteries up so the outwire of the cells would go through the BMS rather than just having the in wires going through the BMS to recharge them. And because he put the outwire through the BMS, it fried the outwire and it fried the BMS. And because the BMS fried, then when I went to recharge it, the BMS board was fried and the voltage didn't disperse correctly between each of the cells, and gaseous clay was born there, which is very annoying. I don't think I'll be trying to reclaim any of these cells. I think they're all buggered. This is what happens when the BMS board is not doing its job correctly and wired up correctly, and sadly the BMS board that was fried, I took out to show you here. This, guys, is the BMS board that was built into the batteries, and which was at the top of them wires up there. And you see the blue wire there, that's the out wire for your output from the battery, and that shouldn't have been there. Just shouldn't. If he or she, the Chinese engineer in China and not England, would have not soldered that wire to the BMS board, it wouldn't have fried this damn thing, and I wouldn't be so annoyed, and I wouldn't have lost a full battery set there. So I thought I'd take this opportunity to show you what I did as a workaround for this a bit dodgy wiring with that blue wire. And I basically took this chip out, and when I was recharging it, I was hooking that little top clip up at the top of it into the 5 wires leading off into these cells here, and then I was hooking up the positive and the negative on this board to the recharger, and the out wire, which was the blue wire that fried this thing, I just left off this board. As you can see, it's not been wired up or anything, and I just run it on the out wire coming out of the battery pack here, and that worked fine because I've been running that for about 2 months on the other batteries, and since this problem first occurred. Basically this problem occurred because initially I was running I think it was a 300 watt motor on my electric bike, and the maximum output of each of the batteries, and there was 4 of them on there for 48 volts of 12 volts each, the maximum output of wattage was quite low off each of the battery packs, where when I've upgraded to the electric bike to 1500 watts, and then the output has gone through that blue wire, which shouldn't have been on that board. It's fried the board, and then when it's gone to recharge, it's gassed these, and then has alerted me to that the boards have all been fried. So I went in each of the packs, I cut out those boards, and that was the last one you could see there that was not fried, and I've been using those since, and they've been working fine. It was literally just the output wire should not have been going through the BMS board, and if it was just redirected directly to the output, you could use it like any other battery and it'd recharge just fine and not burn out the BMS board when you're using it to run an application device. As you can see, this plastic on the right here was not very big, and that's gassed up to about 3 or 4 times its size. It does give us a chance though to have a look very carefully at some of the wiring going on in here. Can I move this out of the way? There we go. Okay, so you can see, guys, that you have this plug that was being plugged in to this white connector here to go in there, and then you'd have the live going off to the charger and the negative going off to the charger, and the engineer in China had the output negative, I think that was. What was it? No, I think it was an output positive going off then from this, where they should have just bypassed this. And you can see that when you recharge, when you send the 12 volts through this little BMS board, battery management system board, when you send the 12 volts through these two wires, the electric gets sent through all these little chips, goes into these wires, and you can see 4 reds and 1 black, and each one of those reds goes off then to a little board here, which just looks like they've glued it heavily on, going across the cells, and it's charging 4 here, I think. Yeah, 4 there, 4 there, 4 there, and 4 there. So it's charging 12 cells in total, and that board's shooting 12 volts off, split up between the 4, and that way we get 3.2 volts per cell at 10 amp hours a cell. So these 4 are 3.2 volts at 40 amp hours, or the 12 volts at 10 amp hours. So we've got 12 volts at 10 amp hours. We have that again, so we have 12 volts at 20 amp hours. We have that at the end again, so we have 12 volts at 30 amp hours. That's where we have the 12 volt 30 amp hour pack. And yes, I wanted to document this one because it's basically, if you do receive batteries, lithium ions like this from China, I would recommend checking the BMS board, see if it's a similar board to this board here. Excuse me. Yep, check and see if that one's in it. Sadly, that blue plastic you'll have to cut off, and it'll look really bad when you gaffer tape it up. But you can leave the plastic on and it'll look pretty, and you can burn everything out and probably gas your battery. Or you can open your plastic and see if this little bugger's in there, and then you can see if that blue wire's on, or see if they've sent the output from the cells that's going to go out to feed your application, your motor say, through this BMS board, and if it has, you can just cut it off and then redirect it to your out and save that pain. So I hope this has been helpful to anyone who's been using lithium ions and perhaps having issues, especially with the BMS boards. And I've just ordered a new BMS board, but this BMS board has got a date on, which is the 12th of the December 2011, and they were pretty new back then, these batteries, and still pretty expensive. But if you guys do need one or want to see what a replacement might be like, then you can check the description out below, and that's the one I'll be replacing this one with. And hopefully from Banggood, which is really awesome. Jace loves Banggood. Brilliant, Jace. I've seen loads of your stuff from Banggood, and it's true, mate, they have some great stuff. Shout out to Jace there. Leave your link in the description below, Jace. So thank you, guys. I'm sorry I've not caught up with you before. Been running around. I've used this artificial light because daylight's really bad at the minute. It's late in the evening. And thank you very much for checking in, and I'll catch you up. Stay safe and stay sharp. See you.